What I wanted to show today is mainly that you can do like that function representation of surfaces and geometry, or use it as like material distribution, and that you can also like use this as a like free painting. It says here like free painting techniques for like sketching in 3D in ways that you could have seen if you've used ever like ZBrush or something. It feels similar to those tools. So the first thing, if you go to, I prepare a small document that I can pass along later. If you go to this generate menu, you have like generate a field defined by a user supply formula, and basically what you can, each time you create one of this, it creates one layer, because Monolith works with layers. And you can put, like, if you go clicking over these buttons, you're gonna start to add a lot of layers on top of each other. And these layers are mainly thought as Photoshop layers, because they have like blending options, like add, multiply, or like subtract other operations. So you basically can think of a model as a set of different steps that get accumulated, and then you can, like, if you click here, you can go and hide. So you can deactivate some of them, or you can keep them, and if you like drag, you can drag them, and like you can drop them in the black hole and they will get deleted. This is a bit buggy on my version, but let's see if that works. You see, you have like that black hole, and they will disappear. So that's kind of the basics of how this thing works. So we can go ahead and like remove some of the layers, and we're just gonna keep one of these function representation layers. So if we click, have you got to this? So I have this one here, the one in the middle. So basically it says generate a field defined by a user supplied formula. So if you click here in the 3 lines, you see that there is like this menu, that there's a floating menu that appears here, and it allows you to define a mathematical formula in 2 different channels, like the shape channel or the material region. So we're gonna go ahead and put like a really simple formula of the sphere. So we can do x by x, y by y. So yeah, on the shape, at the moment, we're defining the shape of the object with this formula. Once you have it, you just press enter. You won't probably see it. So when you got that, you can go ahead and change the ISO values here. That's going to section, like a clipping plane. It's going to section the object. We can also tweak the color of the geometry and the transparency here. Yeah. So when it's let me show you this example. If you look in here, I'm gonna try to explain what that means. So if we set this to fill the whole thing, so this is basically here on the left is the color of what it's called the shape channel, so what defines the geometry of the object. And if we go to material ratio and like copy, you don't need to do that right now. We can do common settings, so it will get the same formula for both channels. So you actually see here that I'm actually getting like a grading of color. I mean, you can see some difference of color from the middle. You don't see at all. See how can I emphasize that? Okay, just going to go ahead and change this. So basically, you can use, so you use a formula in space. You use a formula, and then the model would basically survey, like get the value in each point of space and return a value. So when you do like the spherical field, it would basically have like the center would have the higher like density value of the shape, and then will spreading over space. Depending on the formula, it would be spreading. So for example, if the center value is 1, then it would go like a gradient, it would go to 0 until the field disappears. So the thing with Monolith is that you don't have a shape, a static shape. You have a field. You have a field of like a lot of shapes. So you need to choose the ISO values. That is at what point you want to stop the visualization.
Okay, is it just a range definition?
Yeah, the ISO value is a range. So the thing is that you can actually map the field, and then you get, if you map the field from like I don't know, let's say your highest value is 4 and then your lowest is -10, 0.1 would be, I mean, like an interpolation there, and you will be getting those. Let me see if I can get this formula from here and show you something different. Yeah, I have a set of formulas here in this document that I prepared for this plane. So for example, if I get the formula of a wave, so this formula makes a wave. It's basically like a cosine of x multiplied adding to the sine of y, and changing basically the height of the thing. So we can go and paste this here. Let me see if this allows me to paste. Sometimes it doesn't. Oh, not gonna allow me to paste today. Okay, I'm gonna have to copy the formula. So if you want to copy the formula also, that'd be good. You want to test this one out. This one is a bit more complicated. So when you add something in between curly brackets, it actually means that you have a variable. So you can actually slide. It's like a slider. Allows you to change the values gradually. We're copying this one at the moment. It's a bit complicated, but sorry for that. Yeah, sorry, I'm trying to leave it on the best spot. You get a square? Yeah, because of the zeros. So you will get a square. Yeah, thank you. Do you guys have time to copy it? Maybe? Is it visible? I'm actually gonna give you the link to the document because it's online. So tell me an email. Oh yeah, I'll put it on your Slack. The Slack works. All right. I'm gonna go ahead so we can move on a bit. So what I wanted to show here really is that every channel can contain different formulas and stuff. It doesn't need to all be the same. So you can define the ratio of material with a formula and the shape of the object with another one, and you could imagine that you create a new channel of transparency and you define that with a different function. And I'm gonna go ahead and use this formula. Send. Yeah, so if you check this one out, so what I've done here is apply like a sin function on top of, with like a high frequency on top of the function of the spherical map. So it basically goes from 1 to 0 over space, and it creates a series of consecutive spheres in space that you can actually navigate through if you move this thing. So basically, this would be useful if you want to define, like I don't know, like have a box, but you want it to have inside layers of different transparency, different color, different material. So when you cut a slice, you're always going to see the section of sphere, for example, or whatever section you might define with a function. If we go ahead, I mean, I'm going to leave this on the screen because I don't think this one is on the PDF. If we go ahead and put that here, this doesn't do anything. Okay. Yeah, so you can see this is pretty interesting. Like if you see that definition now for the shape channel, it does this cool effect where we have like a series of spheres one over the other, and as we shallow the ISO values, we get like a thinner and thinner shell of that sphere.
Where do you activate the shape channel?
The shape channel is here, and this is the material. You can make them common settings, so you can actually get. You see, so when you get, and this is the last thing I'm gonna explain of to move on to freehand drawing. So what's interesting here is that if you basically put in sync the shape channel with the material ratio channel, you can see that the areas that are more pink are more dense in this object, and they're the ones that stay. If you put the bar in there to be in the dense areas, is where the material is more dense, and if I go to the other end, is where the shape channel and the material channel are the lowest. So this happens when you use common settings on the material and the shape channel. They're kind of combined over the same field, and if I were to like change the frequency of the field, that will still happen. I will always have that shallow pink area. Oh, this is a bit ugly. Yeah, so that's, I mean, you can think there are a lot of functions, and there are some more that I played with that are on the document. But basically you can play with like, actually I'm gonna show this one that you've probably seen on the Twitter thing, but let's see if I have that here. Yeah, so this one, for example, I mean, I really like this one because this was basically like a three-dimensional sine and cosine function added on top of a spherical one. So it actually merges the sphere with the cubes in three-dimensional space, and you can change the field, and that's where the animation comes from. But just to give like a really quick example on that, you would just come here and define some kind of quick function that involves sine of like x and y on different sine or cosine, and then the c value. So this doesn't really display a lot because it's actually defining just one module of the pattern. But if you increase the frequency of the pattern, you can see all those floating cubes. So I also think it's a really good environment to test with like mathematical, like implicitly defined functions, because actually, I mean, we usually don't understand what like a sine of x or other functions mean. But if you go to like a really simple sine of x and amplify the frequency, you understand what it actually means. Okay. Any questions of this or any thoughts? No. Cool. Yeah. And all of this, I mean, the powerful thing of this is that it's been defined like really dynamically, but Monolith already handles the generation of a tight mesh with that, which is really challenging usually for this type of geometry. So if you wanted to have like a tight mesh, you can just directly export it and 3D print it. And there is also some support for like 3D printing multi-material with like different meshes where you could export like a set of files with different ranges of the material ratio. And you could have like, if you have an object, a 3D printer, you could print 3 different stages, and if you have a gradient, it might do 3 different STL files. Okay. So I'm gonna go ahead and remove this function layer for a moment. That doesn't work. Just gonna close. And I'm gonna go and use this free painting technique tool that you can access through this button, and then you press here to edit to get the painting tools. These menus are a bit small. I don't know if you can see it.
So which tool did you? Okay.
So first you press here,
Yeah.
and then you press in the small hand here, and this will display this menu, so like a set of drawing tools, and you can play around with it. So the interesting way of this works is that it actually projects the three-dimensional view. It projects your mouse in the existing surfaces. So to orient yourself on here, like basically when I click the line, for example, to know where you're drawing, if I put here, it's projecting over the floor plane. So I click, and now I'm moving a line from that point into wherever point I project now. So this is projecting on that lateral plane. And that's basically generating like a line that increases the field in that area. So it's kind of like a way of that Monolith has of generating or increasing the field in a certain space by adding geometry or even free sketching. So we can see, we can continue doing this. So you can get, for example, let's see, you can change the colors here or the opacity of the thing. And if you get this tool, I mean, you can try the tool, but if you try this one, so we have here this kind of printing head or pen. So you can click here as you would do in ZBrush and add like three-dimensional model. So you can actually model stuff real time and even slice it and see what that looks like. So these, I mean, you can imagine that these things are really good for printing internal, like maybe things for biomedics and stuff. Because you can not only define the shape of the object, but now you could go and like kind of color on 3D different parts of it to be printed more rigid or more flexible or have different mechanical properties. Yeah, so that's our wiggly shape. We can create boxes, 3D. Whatever you might think.
How do you clear out your
Canvas?
basic building area? I've got some sort of persistent cube.
So you have the ISO values. So if you take that back, yeah, take it to the middle, and now make it maybe the one line of the yeah. So now if you adjust that, you can see that the field that is being defined by the curve, and if you get that one, and
With the red button.
Yeah, so if you draw like some wiggly shapes, I want you to draw something that seems sharp but has different, something like that. They call. What do you draw? Okay, that's a typical. It just happens naturally.
It just happens.
It has to happen.
Everything goes back.
Mine seems more like a heart or something like.
Well, I have to say this is what has happened with me.
Dude, you have weird stuff in your mind.
Something.
Wow.
Something more enclosing.
Okay, so the cool thing, one of the nice things of this that we're gonna see now. So, as I said before, you can apply filters or different levels. So if we click on this button, on the kernel-based blur filter, is this icon here? There is a kind of a blurry square here. So it says, if you hover, it says kernel-based blur filter. And as soon as you click it, you can see how your shape starts being more soft. So it's actually blurring, and it's applying like if you were to apply a Gaussian blur in Photoshop and then tweak the levels to make the shape sharper. And you actually can see that. I mean, you can see it really, how you go from something that looks like that until something that doesn't have any sharp edges at all, which is pretty nice. And still, the really valuable thing is that you can now leave a couple filters, or like set your filter however you want, and go back to your free painting layer and edit what you have drawn before. So as you paint, now you see everything with that blur effect already applied to it. There is actually undo button here and redo. So they're here. There are two arrows here on the top. You can actually go back on your drawing operations, however you want.
How do we delete some parts that we created as the original one?
You mean not removing, like here? So you can actually, I think, you can actually, so you have to think of this brush as some Boolean operation or blending brush. So you have a set of operations here that you can see. So it's by default it's on add, so I will keep on adding to the field, but you can also use this drop down to say subtract. So if you go here and subtract, it will be the opposite. So you will be actually removing parts from your from your geometry, and you would be like kind of carving out. And I mean, you can here change the fall off of the brush, so you actually make smaller tweaks into your geometry. And yeah, I mean, if you set it really to be really fine, it's actually something like you would do on ZBrush, that you just like put in holes and yeah, like making bumps here. Okay, so everyone more or less familiar with this? So we can, there's a lot to play with this, I guess. So what I would just said, Zach, is that you actually can change the fall off of the brush. So you actually can go to a like more fine drawing size. If you apply these blurring operations, you can still get into your painting layer and draw, and still see that operation when it's being blurred in real time. And you can also like click different blending options for your brush. So it can be subtract, that would be like a removal. Add is adding more stuff, and then there is like this multiply, maximum and minimum, that it will be useful for blending different channels of shape or material and stuff. And you can see here, for example, we're affecting the shape and the material channel. This is what I said before, but you can only like, you can say, okay, I only want to affect the material channel, and probably, like, you see now I'm just painting the object. So if you say that your material channel, when it's really high, that field is really high, it means that it might print more density or more transparent. You can paint this object in 3D. And
Now,
like,
when you're painting that, you were just saying that now you're just dealing with the surface. So that's not actually permeating the...
So you have to, so the thing that confuses a bit, I guess, with Monolith is the shape channel, because it defines the actual geometry.
Yeah.
But everything else is just a map of values from 0 to 1. So if it's on the material, like material ratio, as I'm doing right now, I'm putting the values up and it's displayed as pink. And if you make them lower, it displays it as green, completely green. So when they're in between, it does this kind of orangey color. So that means that you can now change the material ratio channel. But you could think of like, I don't know, you can think of making a mix of material that will have different quantities of magnets inside, and you define that with a new channel. That new channel would appear here, and you will be able to define it with all these same tools, like by drawing or by formulas or all that stuff. So you're basically just defining a set of fields in space with different ranges and different values. So yeah, that's kind of a cool insight. And you can see the internal structure, like you can be painting. And okay, so I'm gonna move on to a bit of the Dynamo stuff that I wanted to explain. So we have this. So any of you was able to install the Voxel2GCode? Were you able to load it?
I still don't have working studio.
Okay, I mean, I like actually that you guys can go through the...
I'm going to mess up my machine recently, so
That's just so good.
I'll watch over your shoulder.
Okay, so yeah. So I've developed basically when you define these geometries that, as you can see here, sometimes get really intricate on Monolith. There is a difficult process or no direct method into translating this geometry, for example, into something that can be 3D printed. There are processes like SLA printing that are really fine detail, and other like micro pattern nano like 3D printing, but those are really expensive, and it's not really a good way to look forward to scale these processes. So this was why I was using the CMOS printer in this project this summer, because this allows you to actually print bigger objects, and it's a process really similar to what could be scaled to like clay extrusion or concrete fabrication. So where the library that I've created takes place is in trying to translate these intricate geometries and internal structure of objects into 3D printable paths, like 3D printable instructions of lines and geometries that can be printed by something like this. For that purpose, I've developed the Voxel2GCode library. You can see that now it's a private repository, but it's basically to transform voxel models into 3D printable G-code. And it has three main components, which are the library itself, which is a DLL that defines the classes and the methods needed to define a G-code model and then generate the G-code. The G-code is the instructions that you put into the printer for it to move and print. Then the Zero Touch plugin, like a package for Dynamo, and then the Grasshopper. That was really useful because along the summer I've been prototyping also in Grasshopper, because the Monolith plugin is fully operational in Grasshopper. That is something that has to get built for Dynamo, but it means that you can use like Rhino. Are you familiar with Grasshopper? No? Rhino? Okay, so Rhino is some 3D modeling engine, and it basically allows you to draw like model in CAD in 3D, and you can get geometry from there and values and stuff to generate the like Monolith models, like these wiggly shapes, and define different properties. So I'm gonna show I have a couple examples. The first obvious step was to build like a simple workflow that allows you to send printing or generate print instructions directly from Dynamo and Grasshopper, or even from code. So what I really tried to do that is different from other slicers, other 3D printing libraries, and that I haven't seen anything really exposed, like you can download for Grasshopper for Dynamo, was actually allowing the person who's gonna print. Wow, that's it. Allowing the person who's gonna print to send printing lines instead of this. Sorry for this, but this is a this is an error I didn't have this morning. One sec. Let's see if this works.
So sorry, the idea here is that you're working from a given shape that was authored in Monolith, and then this is the slicer essentially.
Yeah, but so for the prototyping process, the first thing I built was like a G-code generator from lines. From lines and polylines, curves, it would take let me show you this. But it's basically at the beginning the library doesn't know anything about Monolith, so it's an abstract way of like sending to a device orders on how to move, how much material to put, what speed, and all that behavior that's needed for 3D printing with FDM at the moment, and that could be adjusted. Those parameters could be adjusted for like extruding clay, for example. And basically, the difference, as I said before, is like I'm not just getting a mesh and like slicing it automatically and not letting the user really get into that process, but I'm giving the user the opportunity to draw lines and curves that he wants to print and attach to those objects 3D printable properties, like the speed or the amount of material you want. So you could lay out a set of curves, and in each of them put an amount of material, a velocity, or make different movements, whatever you want. So
you could apply that same thing to any VREP model?
Yeah, any VREP. If you make your own slicing process, or like you make your own operation to generate the lines, so the paths, you generate the paths, and then when you have those lines, you input them and attach different properties. So for example, you could things I tried, not even using voxel models, you could have like a surface, you can slice it, and then each of those curves you rebuild into polylines, and once you have that, you can get the polyline, map the velocity or the amount of material to the z coordinate. so you can have a model that goes printing faster as it goes up, or things like this. So these things are not possible with normal slicers because they just want you to say, I want to print this object, and then at the other end you just get the object printed. But you don't know anything about how much material, how it's behaving, how much it stops between layers, or things like this. Here, what I'm trying to do is that it's possible to customize those, and this allowed me to prototype a lot more because I can basically draw by hand a polyline and see how that translates, like tweaking the values directly. And that was a really valuable thing. I'm going to explain really quickly what's the basic workflow for this, and then I'll show a couple models that we've been building over the summer. So here what I'm doing on Dynamo is basically with a design script component. I'm drawing just this polyline, these two lines, these continuous lines. And this bounding box is a component I made for, so you give the dimensions of a printer, and it will let you know that if you generate G-code outside those, the printer is going to complain. So basically here we're just generating 3 lines, like a polycurve with 2 lines, a polycurve with 3 points. That, as you can see, I mean, as I change the design script, it will just update. So we can change that point, and it will update. What we have here, and this is one of the main components, the library works with a component that is called a printer. So it's a component that just spits G-code, and it gets printing settings and a set of printables. So printables is an abstract class that is meant to be subclass for different objects that you want to use as printables, like points or polylines or curves or even a voxel model. The voxel model hasn't been developed yet, but there are workflows that I have done with them. But basically, it's a way of saying, okay, give me a set of printable objects in order and a set of settings that I'm going to show later. So here what we have is a polycurve. So what would be wrapped into a print polyline, and basically I'm here putting, so I put like the polycurve that you could see on the Dynamo model, and then there is a set of defaults that have been handled for you already. There is a kind of some defaults that make sense, some amount of material that's the most common, and the velocity that is kind of an average speed. And here for the CMO, you could customize the tool head that is being used. You can choose here if it has two extruders, for example, you can specify here, or you can specify a different code that means that it will use both of them. And you could, for example, for the dual pro head, you can specify in each different polyline how much material of each is going to take. So this is how I did those prints that were like with variable transparency. And you would just map, for example, to the Y component or to the density of the voxel model. You will map the mix percentage, so you will get more material from the first extruder and from the second. And then there is like this export component that just basically exports this written G-code. So this is the G-code that basically contains the printing orders. It always has some setup, some initialization. For example, like it heats up at start, it sets. It calibrates itself to the coordinates of the printer, and it prints the model, and then it will like move the tool head backwards and then cool down. In this model, because it's fairly easy, it's just 2 lines, you can see actually what it is doing. So we can look in here. So basically, those commands, like G1 is an interpolation command, and the X, Y, Z are the coordinates of each of the points. So here we're specifying that the printer has to go there at this speed, which is pretty fast. The Z level that it has to be, then it goes to the next point. The E value is basically how much material it has to pour along this line, along the line from this point to this point, and then consecutively it will be doing the same steps over and over. And here is the feed rate, that is the speed at which the print moves. I mean, this is a bit technical, you have to get into the details actually, but these things are the things that I have to learn and actually understand that, for example, like the E value is something that goes incrementing over time, what printing speeds work for what kind of processes, or what's the proper speed to move from one object to the other. So this example I prepared because once you give a path to it, so now I have on the desktop, every time you change this model, it will basically speed some G-code that we have here, and this would be already a 3D printable G-code file, hopefully. So I'm gonna go ahead and just like do this quick test because we can. So the first thing, like I'm heating the extruder head, that it has to be with PLA gets up to 200 degrees and the heated bed gets up to 60 degrees. And as soon as you drag this G-code file here, you can see the same model. So this is kind of the 3D printing software of the printer, and you can see that the G-code defines where that is located on the bed. We can go ahead and connect to the printer. Let's see if that's working. Okay, so I'm just gonna make a really quick change here. So if I were to, for example, change the Y coordinate here to 120, that moves. So we already have our G-code updated. And this works, I mean, this workflow is the workflow I've been using for Grasshopper and for Dynamo for prototyping. We're connected already to the printer. You can see here it says received, so it's basically receiving G-code. Basically works through something called SmoothieWare software, but it's basically this USB kind of like a serial port connection and sending signal and getting a signal back saying like, okay, I got it. So it knows it's connected all the time, and that's what it would be doing every time it sends a command. It will be okay, and then the computer will send another instruction. So now that the printer is at temperature, I can just go ahead and, I mean, you can see the temperature here also. So the heated bed is not still at 60 degrees, but we don't really need that to be. That's the main purpose of that, is that it makes it easier for the filament to stick to the bed and not just wiggle around. So we can just go and print because the printer is connected by USB, and hopefully, is it print? Okay, so I implemented on the library some kind of like an option on the settings that you will tell it if you want it to be heated at the beginning and cool down at the end or not. So if that happens, even though I send the print already, it's waiting until this gets up to 60 degrees. So we have to actually wait. That's almost there. It's at 55 degrees. So let's wait a bit. And this is basically because if you want to send a long print, you don't care that the printer has to wait a bit to heat up. But when I was prototyping, I would remove that option, so you always have the desired temperature. Let's see. Okay. This room is too cold. Okay. 59 degrees. Okay, I'm gonna show another example. Let's see. I don't have the thing to. I actually forgot to bring the spatula. Okay, so this example is basically the same workflow, but just creating a different geometry. Okay. And as you can see, as I drag this different file, it will have like that geometry there. Okay.
So what happens when, for example, for this model?
When what? When what?
For example, for this model, you probably support.
Yeah, so this wouldn't work. I mean, you can, this is the thing with this library, like you can actually define whatever you want to print. You might want to actually just throw material in the air and print that, but this wouldn't work like this. So actually, I mean, what we printed, just printed that like slow arrow, and I'm going to go ahead and print the same one, like generate the same one, but a bit slow, a bit faster. So you see, I mean, what you can, so let's just do that. I'm gonna go faster now. So here you would say like I want a different speed, and you can set the speed to be the 2400. So that's like 24, I think it's millimeters per second. If we go again to a Voxelizer, which I haven't done, it crashes a lot. I don't know why, but every time you leave it like minimized, it will like freeze. So we connect back to the printer. We have this model now, but it tells us that now it's 5 seconds, but before it was a bit more. And we just go print. So now it would just do the same thing, but a bit faster. That's kind of what I wanted you to see. Okay. You see now, I mean, it's just this V shape. Okay, and just like before I get into more like the Monolith workflows that I have been testing with, this is the same example that before, but with the printing settings. So this is something that you have a set of defaults, and you might not want to tweak them because they just work for you. What's the default values? But how this works is that you have the option to input a set of settings into the printer or not, and this also would allow to generate nodes that contain like default settings for like a set of printers. So you could have one component like this that will speed by default the default values for printing with a CMOR or with a MakerBot, but you could still override the default. And I mean, that's useful because it kind of hides all the unnecessary things if you don't want to use it. Here we can define like the start and end point, if the printer should heat up on start and cool down on end. The C offset is useful just because sometimes you want to print over like certain objects, and then you can tweak the bed temperature and the extruder temperature. This is basically because like PLA, ABS, or other materials like fuse at different temperatures. So that's kind of as I was saying before, this is the basic that you would use for 3D printing, but it doesn't know anything about voxels yet. And if we go ahead, as Omid said, this doesn't really have any support. So I'm just going to go ahead and print that. So we have this model here. We can just print it. Let's see. So you're gonna see it's just gonna go printing that object, and it's going to basically throw plastic on the earth. Yeah, so right now it's really low material, so it's actually not throwing anything, but yeah, that's what it means, that you can send whatever you want. And I'm gonna go ahead and make just a test print with this pen. Open source? I don't know actually. Okay, so I don't know. I know it's for Mac and Windows, but I don't know. So I'm just gonna put a text print here. So this one, for example, is one that I did yesterday. That I've been testing these techniques for a while. So here, I mean, you can see why this can make sense. Like, even though the logic says this wouldn't work, it might work. Like, we have here a print that has, so I print one layer so it sticks, but then I separate all the layers like 0.5, 0.8, and then I separate them 0.5 and throw a lot of material, a lot more than it would be usually needed. So what this does is that this distance creates a small pattern where the print is actually like kind of moving, the fact that you throw in more material, it's actually making the object sustain itself just with one line for each of the layers in the shell. And this makes this print, possible, because otherwise you couldn't basically do this if you use a normal slicer. So I'm just gonna go ahead, print that if this works. And yeah, so that's kind of the example that you can just use this for sending any type of curves or points. Yeah, so that'll be printing. And I just have, because I want to leave time for Jose, I'm going to show this last examples. Yes, I don't remember. Yeah, so this one has a small pattern that you can see now. So it's actually, because of that distance and that amount of material, it just creates that mobby thing. Huh. Yeah, so these are some of the prints that I've been working on over the summer. Some of them are like flexible material with NinjaFlex, and these ones actually contain that workflow of translating the voxel model into something like that makes sense with those printing lines. So yeah, there is one of the processes that is actually in those kind of leaf shapes that you can see. That was actually, and these ones, that was actually trying to map the gradient curves and the contour curves in the field of a monolith model into something that can be printed. But at the end, I was extracting that information and generating curves. So curves that at the end will be printed by the 3D printer, because that's what you print. Sometimes I would be like dashing those curves to generate those spheres that have that kind of like, if you have been like putting points of ink in there. And this was the main result that you could see, like making like a grid of lines in like different ways, or even like following those gradient curves and contour curves, and like modifying them, making them sinusoidal waves, so you can actually print them and have like that different density. Let me show you an example right in Dynamo, if the license works, because something showed up. Okay, so this example, which is actually using the Monolith library, so really quick, all this thing basically is to display the use of this component, the curved sinusoidal points, where you would input like a straight line or like a curve or a curve, and it will basically generate this pattern along that line. And if you are to like put that over like 0.2 intervals of millimeter, it will actually print as a wall, like a continual wall. So this is one of the tools that was useful in like prototyping with the Monolith library. And yeah, you can see here, and this one actually, that Pang helped me with, this one actually, you will input like a set of lines. It would randomly pick one, usually the first one or the last one, and it will make, it will get the shortest path to print those. So the obvious way that the printer would print these lines, if you input it, it would be like, we go this line, then get back here, get back here, get back here, and that will leave a lot of material that you don't want in the middle. What this does is that once you finish one line, it will look for the closest end or start point, and I mean, it's just a simple algorithm that actually decreases the printing time, the amount of material, and makes the printers, the prints more like cleaner. And then all these things I used in something like this. You cannot see anything at the moment, but I'm gonna show a live example, and this will be the final thing. So as we showed before, you can do hand painting in Monolith, so we can put like one line here, and now like maybe like just change something darker. Yeah, so I just want to see, so I'm gonna do something that is dense on the top but only has a few things on the bottom, so you can see that. So I just want to see, like, this is the section as it appears here. We're gonna have two of this here, and this is a monolith model, so I haven't really tweaked anything. We're gonna apply filter, maybe not that much, just leave it like that. So if I export this vol file to like, for example, sample.vol, what I've done in this workflow is that you can browse file and it will be displayed here. So it will change the frequency of those sinusoidal curves. You can actually survey different levels. So at any level, the printer, so this would be one way of inputting a workflow from Monolith into 3D printing, because all these are printable paths, which are basically polycurves, and are expressing the geometry in that model I just drawn. So you can like link your Monolith model into vol file, and every time that you refresh, it will update. So I have a couple examples prepared for the workshop here. So for example, the sphere one you don't see that much because you will have to map to make the more, I don't know if you can see a bit more in the center. Oh, this is actually the sphere mixed with the sinusoidal pattern, so you can actually see the kind of the wave pattern would be there, where you have like lower values here and higher values here. Simple sine wave on space would be like this on the y-axis, and this would be the opposite axis.
If 7 or 8 material nozzles for 3D printers were easily swappable and expandable and cheap and accessible to everybody, would you want to have this pursuit of a method? Because as I understand it, what you're doing sort of like on a high level is you're approximating these material characteristics with single lines, right? Because that's the technology that's ubiquitous and available to everybody. So if those limitations were off in terms of like the ability to get these crazy ass machines that have lots of materials, do you think that this would still be a valuable thing to pursue?
I mean, the thing with the sinusoidal waves?
Well, I mean,
or I mean,
it's basically, I mean, the way it seems to me is like this isn't a criticism, by the way. I'm just trying to sort of figure out sort of different motivations. Doing mesotin or etching style prints in cross-hatching is an effective and expressive way to define shape and form and color gradients in drawing, even though we still have full color ink ways of representing pictures. And that's the way that I think that I'm understanding what it is that you're doing here, is that you're creating an abstraction of something that is sort of a more clearly defined shape in Monolith, but rather than sort of taking a color photograph of it in order to reproduce it in print form, you're turning it into like
hatching. Yeah, I mean, yeah.
Of reproduction.
I think the example I wanted to expose there with the lines is trivial. I mean, it's just a way of mapping, so you get Monolith. So there is a way of actually reading Monolith models and having the space values and modifying a curve there that you could change, like, I don't know, the size of a sphere, the amount of line, all that stuff. So that's just one example of how a workflow could be for this type of printer. That's really specific in here. But this, for example, I mean, where you have like different patterns, scattering lines or different paths, I think for what happens if you have, I mean, if you had like a really fast and like machine that could print like different mixtures of concrete and make it really perfect, like the SLA but big, that would be amazing. But probably it's gonna take a while. So the thing I think on the inside on the project is how to actually make something with these limitations. I mean, embracing the limitations of these printers. I don't know if, because like when you think of like just material distribution or like color, it's okay. But when I did this model, for example, actually here you were like trying to think how you 3D print, putting less density of material but still like keeping the layer high. Those are the challenges that are there, and I don't think it's that easy to solve. I mean, it's more on the geometry, so it will be more about studying the geometry and the way of printing it than the machinery and stuff. Like it might be able to be done with this, but you need to actually have the workflow, I think, or the actual geometry to conform that in 3D space. But yeah, of course, I mean, I've been using plastic. Some of these things in clay are obviously not going to work. They will fall off or not stick properly. So I think, yeah, I don't know if I understood exactly your question.
Well, I guess, I don't know, it seems like there's a very straightforward, similarity between, what we're doing with, any kind of color print output for, flat documentation of anything. Our money is still printed with a basically etching and line-based process, even though we have photography.
Okay.
And we have chosen not to do photographs on our money for various reasons. So what I guess I'm wondering is how. I mean, there's an obvious there's a pragmatism to your approach, which is to say, this is the technology that we have right now, and we can make it more expressive in terms of what it does by altering sort of speed of placement and how we layer things on top of each other. At some point, our technology capabilities are going to shift to the point that we can, do 9 different kinds of materials and just sort of have this sort of photographic kind of accuracy relative to the kind of material that we want to print. And at that point, what is the role of this kind of work? Which is, I mean, I'm just trying to sort of imagine further down. The fact is that we still use all sorts of older processes that have not been made obsolete in sort of photographic reproduction. And it just seems like there's a lot to sort of learn and take with the similarities of those two processes. I mean, what's cool is that this is here right now. We can use this right now to do all sorts of things we can't do with most printers, or with most software that's feeding it.
To me, I think that it will have to be like a longer research process. But there are 2 factors. There is one is the way that you send the instructions to the printer, and the other how you survey that monolith model like just reading the value, because you might use this library and forget about what I've done with the sinusoidal curves and just use it for a different way. I mean, you might just, I don't know, you might like maybe put lines and scatter them and add more lines next to it when there's more density. But yeah, I mean, at the end of the day, I don't know if it's the best process or. But I still, with the line drawing thing, I always think that it's a bit also like serigraphy, that you actually have to export the image in a different way with like maybe circle patterns, more hidden patterns, even though you have other projects. It might be because like repetition is cheaper, or so yeah, I don't know. So yeah, I mean, yeah, so that's wrap up. So yeah, that's been it. Thank you everyone.
No, kita balik. And then you have Dynamo as well, which should help your, that's the that would be ideal, okay? Otherwise, you can go to their, their homepages and stuff and download and install it.